what we're doing or what we're wondering about is what we need in terms of metabolic support in order to keep especially mesenchymal stem cells alive for implantation. So basically what we're having right now is that we're having a large challenge in the tissue engineering field where all of our implants are basically dying if we try to scale them up towards clinically relevant sizes because of the diffusion limitation of oxygen and nutrients. And what we're trying to achieve is to figure out what metabolites and how much of it basically do you need in order to keep the cells alive, in order to give the cells metabolic support, because we realized that after the implantation, the lack of oxygen is not per se toxic to the cells, but it's more the lack of the nutrition basically. And we are now trying to do more of a fundamental study, I would say, in order to figure those minimal metabolic needs out. Yeah, I think that is roughly it. Like to get more specific, I would say, or I can say, we're now doing this metabolic library. Basically, we're testing a whole range of metabolites. So we have sugars, we have amino acids, fatty acids. Just some metabolites chosen based on the metabolic pathways and based on their overall potential, we thought, for keeping the cells alive. And then also, for example, for the fatty acids, we checked what fatty acids do we have mostly in our bloodstream, or can you find, for example, in serum that we add to the cells like in normal 2D culture, and see how they will do basically. And then in order to figure out the minimal needs, we are using or would like to use a microfluidic device, like a gradient generator it is. So you can create multiple different concentrations basically on one device, easy parallelization of testing different metabolite concentrations, and then going from there to see where do the cells remain alive basically, what is the minimal concentration where the cells are still alive, basically based on live dead, for example, like imaging techniques. And then later on, basically, we go reverse way. We want to see where do the cells remain functional. And then functionality, you can see, or we still have to see how we want to define it. For now, we're looking into the survival aspect, basically.